Hi everyone, so in today's video, I'm going to talk about how to identify correlated independent variables in a dataset and then what to do with them. Okay? So for this illustration, I am going to use the data file called Butler with gas consumption. And in this data file, basically we build on the data that we have looked before, or we have worked with before, where the Butler trucking company is trying to get an estimate of the travel time based on other variables, right? So for example, in assignment 1, they have the data about how many miles has been traveled, how many deliveries has been done, and in this case, I'm also adding another independent variable, which is called the gas consumption. Okay, so how we have the data in this case about how many miles does the assignment need to, does the person need to cover for this assignment, how much gas they spent, how many deliveries did they do, and what is the time that they took. Okay, so previously we had data where we had miles, deliveries, and time. Here I added one extra column, which is the gas consumption, right? And the manager is again trying to get an estimate of time or predict time based on all these independent variables, which means that time is going to be the dependent variable in our model, which means time is going to be the Y in the Excel setup. And the rest of them, miles, gas, and deliveries are going to be X or independent variables, right? So now here, first thing we're going to talk about is that among the independent variables, which means miles, gas, and deliveries, do we think that two of them are there are two independent variables that they could be correlated with each other very strongly. And if we just think about it a little bit, it's probably very clear that miles and gas should be highly correlated with each other, right? What this means is that if you travel more miles, then probably you are gonna consume more gas, right? So they are highly correlated, or they are positively correlated, right? So if miles increases, gas should also increase. Now, it is not a good idea to have independent variables in a regression model which are correlated, okay? Because it's just, you don't need that independent variable, right? So if you have miles, you don't need the gas, or if you have gas, you don't need the miles. So basically in this video, first I'm going to show you how to kind of determine which variables are correlated and then what to do with them, okay? So again, you start with an intuition looking at the independent variables, which two might be correlated. And we think that miles and gasoline should be or might be highly correlated. In some cases, you don't have an idea, and in that case, you would use statistical methods to determine that, and we will go over how to use those either. So just first to get a visualization of if these are correlated or not, the first thing we need to do is do a scatter plot. Okay, so let's do a scatter plot between miles and gas. So I'm just gonna select all of that, and you should be able to do this by yourself by now because we have been before. We have been doing this, I think, for the last couple of weeks. So you select all the data and then you go to data. I'm sorry, you go to insert and then do here charts and then do scatter. And then what you want to do is also write what the X variable is. So to do that, you want to just select the chart and then here add chart element, axis title, primary horizontal, which is going to be miles. So this scatter plot essentially validates our intuition, right? In the scatter plot, we see that there is a strong positive correlation. This is like a straight line increasing slope, which tells us that if miles increases, the gas consumption also increases. And it's kind of like steady, right? So this is like a scatter plot or a visualization way how you figure out that two variables are correlated. However, in certain cases that a scatter plot might not be as clear as this, right? And then we might be like confused how to figure out what the scatter plot says. And for those cases, what we need to do is calculate something called the correlation coefficient between two variables. Okay, so next I'm gonna explain to you how to get the correlation coefficient, and then how to decide based on the number that we get as a correlation coefficient, whether those two variables are correlated or not. So correlation coefficients. Now the correlation coefficients are always calculated between two variables, right? So you cannot calculate a correlation coefficient between miles, gas, and delivery altogether. So whenever you have data, so basically here in this case, I have three independent variables, miles, gas, and deliveries. So what I'm going to do is I'm going to calculate the correlation coefficients for all pairs, possible pairs. So I'm going to start with miles and gas first. So miles and gas. So the formula that we need to use for calculating the correlation coefficient is called CORREL. Okay, it is spelled as CORREL. And then you need to give Excel the two pairs that you are comparing. So in this case, we're comparing miles and gas. So I need to give them the full array of miles and then the full array of gas. The order that you are giving Excel this doesn't matter. You could start with gas and give miles if it's gonna be the same. Okay. So and then one more thing to remember is that when you are giving Excel this array, you should only give numbers and not the labels. Okay. So I'm gonna select this array first. And then comma, and then this array. All right. And then you close the parentheses. So there you go, you press enter and this is your correlation coefficient. So now let's calculate the correlation coefficients for miles and deliveries, right? So let's try to calculate for all pairs possible. Again, the function correl, and then 1 and 2 miles, and then and finally miles and finally gas and deliveries. So correl, gas, and then deliveries, right? All right, so now we have these numbers. So from these numbers, how to tell when some variables are correlated and some are not. So these numbers are always greater than 0, but it could also be less than 0. So the correlation coefficients are generally within this range, -1 to 1. Okay, so it's going to be somewhere between -1 to 1. All right. Now, how to decide whether the two variables are highly correlated or not? You just look at this number. And you look at this number and ask the number itself, excluding the sign, okay? Or you can take like the mod of the number. Is that greater than or less than 0.7? So you're gonna look at number itself, right? So the threshold value is 0.7, right? So that's gonna tell you whether it's highly correlated or not. So if I think about now is highly correlated, So the first one, and my threshold is 0.7. And again, you need to look at the number itself, not the sign. Okay, so if there is a negative before that, ignore the negative and just look at the number itself. Is this highly correlated? Is this greater than 0.97? Yes, it is, right? So the answer is yes. Is this number greater than 0.7? No, so the answer is no. And then is this number greater than 0.7? No, so the answer is no. So what this means is that miles and gas are highly correlated, which means that in the regression model that we want to finally give or suggest to the manager, we should not have both miles and gas in the model. Okay, we have to get rid of one of them. So now the question became that which one? Should we get rid of miles or should we get rid of gas? Now regression is going to help you to answer this question. So what we'll do next is that do a regression with time as the y variable and miles, gas, and deliveries as the x variable. And then we would look at the statistical significance of these independent variables. The variable that is not statistically significant, we would get rid of that variable. Okay, so between miles and gas, we should be able to find that one of them is not statistically significant. And we would get rid of that from our model. So let's quickly do that. Go to data, solver, and then, I'm sorry, not solver, data analysis, and then regression. So your y is going to be time, which is already selected, great. And your x is going to be all of this. And I'm choosing my confidence level to be 99, but it doesn't matter. But I just want to see that so if I choose 99% confidence level, that I'm basically going to be able to see the 95% as well as the 99% confidence interval for this the coefficients for this independent variable. So that will help us make the decision more rigorously. So, and then the output range, I'm going to put it here. And wait, okay, so my y is all of this 301. Yeah, so now it should work. Okay, there you go. So this is my regression result. And now we need to look at which of the independent variables between miles and gas are actually not statistically significant, right? So we could look at the p-value really quickly here. So, and the p-value tells you so here, if you look at the p-values, the p-value for the miles, that is definitely lower than or less than 0.01, which is the confidence interval, which we chose 99% confidence interval, which means our alpha, our level of significance, is 0.01. And we see that the p-value for the miles is actually lower than 0.01, which means that miles has a statistically significant relationship with time. Now moving on to gas, we see this p-value is 0.19, which is greater than 0.01, and then which means that gas does not have a statistically significant relationship with time at a 99% confidence level. And finally, looking at deliveries, you see that this number is again less than 0.01, which means deliveries does have a statistically significant relationship with time. You can also confirm these findings with the confidence interval right here. And just basically looking if 0 is contained in this or not. So in miles, 95% confidence interval, 0 is not contained, neither in the 99% confidence interval. For gas, for 95% confidence interval, 0 is contained, And same for 99% confidence interval, 0 is contained, which means there does not exist a statistically significant relationship between gas and time. And finally, for deliveries, 95% confidence interval does not contain 0, and neither does the 99% confidence interval, which means deliveries does have a statistically significant relationship. What does it conclude? It concludes that in the regression model that we propose to the manager, we should not have gas in the model. So basically, we don't need the gas data, right? So we don't use the gas data to make our regression model. We would just use miles and deliveries, and that would be all. Okay, so that is all for the correlation coefficient and how to identify correlated independent variables and what to do with them. Okay.